Hello everyone, this is Professor Wei here. In this video, I want to give you guys a review of the regression analysis. And also I want to lead you to work on an exercise problem based on the US housing data from the uh, St. Louis Federal Reserve Data Center. Okay, so let me share my screen. So a few weeks ago, we covered the topic of regression analysis, which is a very useful tool to, conduct study in virtually all the social sciences, especially when you are interested in exploring the relationship between two variables or among multiple variables. You are going to use the regression analysis. So in the class, we discussed the example of the potential association between students' performance and the size of the class. So on the screen, you can see the idea of a regression analysis is you want to present a potential linear trend to best characterize the association of the two variables you selected. Okay, so for the student performance, which is captured by your y, is proxied by the student's test score, student's performance. Okay, the x is proxied by the students to teacher ratio. It's not necessarily the physical size of the classroom. Okay, and just look at the regression line fit. Okay, clearly there is a negative association between these two variables. So it means that if the student to teacher ratio is going higher, the test score of students will be going lower. So there is a negative relationship. Okay, or in other words, if the size of the classroom is, the size of the class is larger, the lower the student's performance, which is kind of a consistent with our intuition, right? But to explain the economic intuition behind the scene, it could be a little bit more challenging, which is associated with a discussion you guys presented in the first homework assignments, right? The reverse causality, endogeneity, and we discussed that in the classroom. There are many other factors that can potentially explain the students' performance, right? So the slope of this line, beta, captures the correlation of these two variables. Clearly, in this case, the beta will be less than 0. It will be a negative number because it is a negative association. The whole point of the regression analysis is we want to present a trend of that data by minimizing the squared distance of each observation to the estimated line fit. Okay. So on Canvas, what we are going to do in this video is that we want to work on an exercise. The file is posted over here under the learning module of a regression exercise. Regression exercise problem, US housing data. So just please download the file. Let's read through the file and work on the question together. Okay, hold on. Let me reshare the screen. Sorry about it. So here is the question problem statement. So what we are going to do is to use the US housing data from the Federal Reserve Data Center. Okay, so the link is over here. You can just click the link. It will lead you to, I don't know how come it doesn't work. We can just Google search FRED data center. So this is one of the most commonly used data platform by financial economists. So over there, you can find tons of macroeconomic characteristics such as unemployment rate, wages, inflation data, virtually all the economic data you can think of. Okay, so we are going to use the housing data over there. So specifically, we want to explore the association among general housing price level, active listing count, and of course, the labor force, participation. Okay, because the labor force seems to be a plausible explanatory variable of the housing price. Okay, so what we want to do is to download the data, merge the data, get a time series plot of the variables we're interested, and also we want to present some basic summary statistics to characterize the statistical distribution of the data. Okay, recognizing the data frequency, and then we want to just get some very basic statistics. Most importantly, we want to run the regression to explore the association of the housing price and the labor force, as well as the housing inventory. Okay, so these on the bottom of my problem statements, there are three variable names. This is the names written by the data provider, Federal Data Center. So there's no question about it, and just follow the the naming convention to locate the variable name. So virtually all the data vendor, each variable you have to get a name to locate the actual data. Okay, for example, you can just copy these active listing counts into the Federal Reserve Data Center. You can see this gives you the housing inventory active listing count in the United States. Okay, so what we want to do is to download the data over a sample period from 2018 to the current time point, which is around, I think that's more than 5 years data, right? So let's do it one by one, just download everything. So let's download the active listing count first by specifying everything from 2019 to January 1st to what do we have right now is well, by the time I'm recording this is the February 26th, 2024, but the data, the most recent data is up to the end of 2023. Okay, so let's do 2023, December 1st. So you can, on the screen, on the right-hand side, you have a download button. It will allow you to specify the data type you wanna download. So basically, we are working on the CSV file. So just download the data. It's in my case, it's downloaded to the my local folder. It's in my downloaded folder. Okay. Now let's work on the second variables that we are focusing on, which is the median listing price in the US. So just copy it to the search bar. We have the housing inventory. It means how much inventory we have in the housing market. Okay, so let's go to 2018. Oops. Let's do 2018. January 1st to 2023, December 1st. And again, we are going to download a variable. The third one is the number of the employees in the construction sector. Okay, because we are focusing on the the housing market. So obviously we do care about the particular employment at the construction sector. Okay, so 2018, January 1st to 2023, December 1st. We just want to be consistent. So download the file. Now choose the CSV. We have all the data files collected. Okay, so what we want to do is to open up every single one of them. Okay, so want to be mindful that we have to create a new Excel spreadsheet. Just we have to copy everything to the clean spreadsheet. So let's do the active listing count in the first place. Okay. Now let's work on the what else? Median listing median listing price. Oops. We copy it to the new file. Hold on. And then we want to move on to the last one, and that is the employment. All right. Now let's just save the file to be safe. So regression analysis, US housing. Okay. Okay. So now why don't we just change the variable name to be more readable. So listing price. Oh, hold on. Oh, sorry, active listing count. Price. And then let's do labor. These are the variables we are going to work on. And the first one is obviously the date. Oops. Okay, so the sample period spans from January 1st, 2018 to December 1st, 2023. So it's pretty much a very long horizon. But notice that the data frequency we have is pretty much consistent, and that's the monthly frequency, right? So what do we want to do in the first place is to plot the time series of the median listing price and the active listing count. Okay. So let's just highlight everything over here. We can just simply insert a graph from the Excel. So clearly it's not very readable because we only use one single axis. Let's just call it a time series property of US housing. Okay. And the evidence is from the housing inventory and listing price. So just a quick note, whenever we work on the data visualization, we want to be very careful to label everything, specify the variable name, put a legend title clearly in a graph so that it's going to be reader friendly. Okay, in this case, we have a sample period from 2018 to 2023. Okay, so now it's actually still not very readable because both variables they share the same y-axis, which means that it's not going to be very readable if they share different magnitudes. That's what we are experiencing right now, right? So I remember in Excel, we can do double axis. Let me see. Uh, let's see if we can change the hmm. So okay, let's do more axis options. Uh, hmm. Okay, why don't we just go online and search how to do the double axis plot in Excel. Okay. Excel plot. Okay. So it's design, chart type, combo cluster column. Okay, let's go with design. Uh, Interesting. Hmm. Let me see. Oh, I think it's somewhere here. Secondary access. Oh, I see. So you can see on the Excel, when you single click on a line of one of your variables, I don't think it matters. So when you click on the any one of this, there's a little icon over here under the format data series. Okay, so you have a series options. You need to specify this is your secondary access. Okay, so clearly, if you place a label like this, okay, double axis, it's going to be much more readable with a reasonable style that properly presents the fluctuation or the trend of both variables. Okay, and as you can see, I rarely force myself to memorize all these technical details because we can always go online and search the solutions. Okay, and actually, this serves for another reason why I personally do not like Excel, because you have to memorize specifically how to locate the those Excel function buttons on the operation panel. It's just a personal preference. I feel it's gonna be very it's almost impossible for us to scale our work. Let's say if we want to update the data in the future, it's almost impossible for us to automatically update everything, because you have to manually use your trackpad to to do the double axis. So again, you just need to a single click on one of the variables. There is a little button over here. It's called a format data point. Sorry, under the format data point, there's a little tab. You can select the axis to be either primary or secondary. So on the left-hand side or the right-hand side. Okay. Now, so basically, this presents a very preliminary time series property of the two variables we highlighted. Okay. And now let's do some basic summary statistics based on these variables. So what are the mean standard deviation of each variable, and what's going to be the monthly growth rate of the median listing price? Okay, so let's do summary statistics. Okay, so the mean, median, standard deviation, and now we have listing counts or inventory, price. So basically, we can calculate every single one of them using the Excel functions. In this case, we have average of listing counts. And also we have median. Oops, sorry. And we have standard deviation over the sample. Okay. And now we have price average being the average of this data series over here. And the median is and the standard deviation. Oops. Oops. Okay, so this is essentially the summary statistics we produced. of the sample, okay, using the Excel formula. So basically, we use these few parameters to gauge the statistical distribution of the sample. Mean and median is what we call the central tendency measurements of the sample. It means that on average, what is the level that represents the listing counts and the price, and standard deviation capture the dispersion of the sample. What's going to be the distance of the observation to the central median or average. So it is sort of a notion of volatility under the context of stock return. Okay. So then what we want to do is to implement the regression analysis. We want to use the housing inventory to explain the listing price. Okay. So before doing that, we want to take the natural log of the data to make the to kind of standardize the sample to make it more stationary. Because you can see these numbers are very huge. They are not on the same magnitude, especially for the labor. You can see just completely different in terms of the scale. Okay, so let's do inventory log. Okay, and you do that for both price and the labor. We have labor log form. And we can transform all the data across the timeline. You can see it's much more readable, right? So these are the data we are going to use for our analysis. So the first regression is that we want to explore the association between the housing inventory and the listing price. Okay, so we want to prepare the regression inputs, go to data analysis, regression, okay. So the Y will be the housing price, right? And we have X being the inventory. Let's check out the len fit. See, there we go. And this is the oh, actually, sorry, I think I need to check the variable name to make sure it's more readable. Let's just start over. I forgot to check the label. So let's go back to the data analysis, regression, and I wanna highlight. So the Y is the the housing price. And we want to check the label, and the X will be the inventory. Okay, now Let's run the regression one more time to see. Just beautify the graph. You can see. Okay. So this is the regression line fit. We plot a line that captures the linear trend of the housing price with respect to the inventory. Okay, so the supply is going higher, then the price level will be going lower. More supply leads to the uh, lower price, given the sample we have. Okay, now, and you can see the t-stat is highly statistically, it's pretty high, and the coefficient is negative. And we have a R square around 50%, which is quite reasonable. We have now a number of observation of 72. Now let's look at the association between the labor force and the listing price to see if there are any pattern. Hold on, let me see. We want to run the regression of labor force with respect to the the price with respect to the labor force. So go to data analysis, regression, and the Y again is the housing price. This time we want to change the price, your X independent variable to be labor. You can see clearly there is a strong linear relationship between the labor and the housing price, right? So the cost of labor is going higher, the higher the housing price, which is validated through the statistics. That is 8 or actually 9, which is huge compared to the critical value. And the beta coefficient on the log labor measure is 2.7. So 1% change of a labor force will result in 2.7% change on the log price. Okay, so that's how we implement the regression. Okay, but of course, there could be a much deeper discussion with respect to the potential deterministic factor of the housing price. What if we include some other factors like macro variables, including the inflation, financing rates, short-term rates, long-term rates? I believe all of this can play a joint role in explaining the housing price. Okay, so but anyhow, these give us at least a minimum result for us to interpret the housing price. Okay, so try to revisit the whole process and come up with some other factors, and then download the data again, try to use some other plausible factors to explain the housing price. It's going to be a very meaningful exercise. But looking back, you can see this process it's actually not very efficient, right? We have to download everything. We have to, manually specify the parameters on Excel to draw the graph. You can see even being a professor, I don't even remember how to, just insert a double axis graph instantly, right? So the whole thing motivates us to think about how to automate everything in a more advanced platform. That's something we are going to work on very soon. Okay, so in the rest of semester, we will definitely revisit this exercise or this type of exercise to run the regression in Python. Okay, that's going to be our next focus. But right now, we want to make sure you are comfortable with implementation like this. Okay,